Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif Aiman. I am from Group 6, Section 01. My group member is Kevin, Kumar, Lim Chuan Yi, Tuan Muhammad Izzat, Muhammad Arif Aiman, Nur Aina Zafirah, and Adam bin Saiful Anwar. So we will present about thermodynamics theory. So our lab is concentric tube heat exchanger. I will start with introduction. So, heat exchanger may be classified according to their flow arrangement. In parallel flow heat exchangers, the two fluids enter the exchanger at the same end and travel in parallel to one another to the other side. In counter flow heat exchanger, the fluids enter the exchanger from opposite ends. The counter current design is most efficient in that it can transfer the most heat. In a cross flow heat exchanger, the fluids travel only perpendicular to one another through the exchanger. Continue introduction. For efficiency, heat exchangers are designed to maximize the surface area of the wall between the two fluids. While minimizing resistance, two fluids flow through the exchanger. The exchanger's performance can also be affected by the addition of fins or corrugations in one or both directions, which increase surface area and may channel fluid flow or induce turbulence. So for experiment procedure, say what you will do in this experiment. They have two: heating of hot water tank and experiment method, which is a counter flow measurement and uniflow measurement. So for the first one is heating of hot water tank. First step is check water level in tank and top up if necessary. Next, switch on master switch. Next, set desired hot water temperature at thermostat. And the last one is switch on heater. Heating from an ambient temperature of 20 Celsius to 60 Celsius requires approximately 20 minutes. Next, counter flow measurement. First procedure is open the ball valve 2 and 4 while close the ball valve 1 and 3. Cool water now flows through the heat exchanger in counter flow modes. Second one, switch on the centrifugal pump and set the hot water flow rate V1 to 50 for 1 hour. Adjust the cool water flow rate V2 25 for 1 hour, and next wait until the thermal steady state condition is established. Temperature change for temperature 3 and temperature 4 are less than 1 Celsius per minute. Then enter the temperature 1, temperature 6, and hot water flow rates V1 in the table. Repeat step 3 to step 5 by varying the cool water flow rates V1, V2 to 50 in 1 hour, and 75 in 1 hour, and 100 in 1 hour. Next, repeat the experiment by adjust the hot water rate V1 to 100 in 1 hour. Switch off the heater, centrifugal pump, and cool water supply after the experiment. And then, last but not least, draw up the average temperature profile, which varying the thermometer location in the same graph for 2 hot water flow rates V1, cool water flow rates V2. Next, uniflow measurement. First procedure is open the ball valve 1 and 3 while close the ball valve 2, and 4. Cool water now flows through the heat exchanger in uniflow mode. Next, switch on the centrifugal pump and set the hot water flow rate V1 to 50 in 1 hour. Next, adjust the cool water flow rates V2 to 25 in 1 hour. And then, wait until the thermal steady state condition is established. The pressure change for temperature 3 and temperature 6 are less than 1 Celsius per minute. Enter the temperature 1 to temperature 6 and hot water flow rates V1 in the table. Next, repeat step 3 to step 5 by varying the cool water flow rate V2 to 50 in 1 hour, 75, 1 hour, and 100 in 1 hour. Next, repeat the experiment by adjust the hot water rate V1 to 100, 1 hour. And then switch off the heater, centrifugal pump, and cold water supply after the experiment. And then draw up the average temperature profile with varying the thermometer location in the same graph for hot water flow rates and cool water flow rates. Next, refer to counterflow and uniflow data sheets 50 in 1 hour and 100 in 1 hour. Plot coefficient of heat transmission with varying cool water flow rates.
Assalamualaikum warahmatullahi wabarakatuh. My name is Tuan Muhammad Izzat bin Tuan Muhammad Fauzi. My matric number MA19357 and I'm from section 01. So now I'll explain about the data and result for this experiment. So this is the data given from this lab. This is the data counterflow and another one is the data for uniflow. For each data we have flow rate for hot and flow rate for cold. Next, this is the result for this lab. This is the result for uniflow. For the uniflow set 1, T1 is the TH in, T2 is the TH out, T8 is the TC in, and T7 is the TC out. For set 2, T3 is the TH in, T4 is the TH out, T6 is the TC in, and lastly T5 is the TC out. Next, the calculation for uniflow. From table A9, we can find the temperature, density, and the specific heat. And this is the formula to find the rate of heat transfer for W1 and W2. These are two graphs of uniflow from this experiment. Next, this is the result for counterflow. For counterflow data set 1, T1 is the TH in, T2 is the TH out, T7 is the TC in, and T8 is the TC out. For set 2, T3 is the TH in, T4 is the TH out, T5 is the TC in, and lastly T6 is the TC out. This is the calculation for counterflow. From table A9, we can get the temperature, density, and specific heat. And this is the formula to find the rate of heat transfer for W1 and rate of heat transfer for W2. From counterflow result data, this is graph that had been derived from the table. So that's all from me. I will pass to the next presenter. Thank you.
Assalamualaikum and hi, my name is Nur Aina Zafira binti Zainuddin and my ID is MA19318. So in this video, I'm going to present to you the discussion 1. For the discussion 1, we have to calculate the unknown value of kW2, kW1, km and also total TLN with the help of the formula in appendix. So for the kW1 and kW2, we use the formula of Q equal to CH, open bracket TH in minus TH out, close bracket. Where the CH we got from the formula of M multiplied with Cp, while the M we get it from the multiply of the rho with the V. The V is actually have been given in the data, however, we have to transform the unit into M cube over S. For the rho and Cp, we get the value from the table A9 using the interpolations. Next, for the km, we assume that km is equal to U because they have the same unit. So, for the formula, we use the formula of km equal to QWM over with the AS multiplied with T. Kilogram M is actually the mean of Q1 and Q2. Meanwhile, for the AS, we use the value from the heat exchanger PDF, and for the total T, we use the formula of total T2 minus total T1 over with the ln open bracket T2 over T1 close bracket. For the T1 is actually the TH in minus with TC exit, and for the T2 is actually TH exit minus with TC in. So next, for the total TLN, we assume that the formula is total T inlet divided with the total number of T in. So the result will get in terms of Celsius. So we have to transform the Celsius into the unit Kelvin. The result have been shown by my friend before we discuss how we calculate for the this value. So I think that's all from me. I will pass to the next presenter.
Hi, my name is Adam bin Saiful Anwar, MA19150. For my part, I'll be continuing on the question 2 and 3 for the discussion. Let's get straight to the question. Based on graph 1, 2 and 4, explain the difference between counterflow and uniflow and how the temperature profile and heat transfer rate affects. So you can see from the figure below, parallel flow with the hot and cold flow are the same direction. Counterflow, hot and cold fluid flow are the other way of direction. So counterflow makes higher efficiency and heat transfer in heat exchanger because they creates a more uniform temperature difference between fluid over the entire length of the fluid path. Basically, just cold water is escape the heat exchanger quicker compared to the parallel flow. For question 3, what is the coefficient of the heat transmission? Heat transfer per unit area per Kelvin. The formula for calculating coefficient. So coefficient be calculated to the rate of heat transfer between mediums. So the value basically to calculate each chamber of coefficient of heat transfer in the mediums. The value changes by mass flow, surface roughness and fluid and material properties. So continue to the next. Thank you.
Great day everyone, my name is Kavin Kumar and my ID number is MA19020. I'll be explaining the discussion part of our experiment, which is from question number 4 until question number 6. So let's have a look at question number 4 first. As for question number 4, what is the factor that will influence the coefficient of the heat transmission and how it will be occurring? So the main factor that will be influencing the coefficient of the heat transmission is the thermal properties of the liquid which is used in the system, the hydrodynamic characteristic of the flow, and the hydrodynamic of the thermal body condition as well. This is because the higher the heat transfer between the medium and the space, the higher the heat will be able to be transmitted throughout the whole system. As for question number 5 is, what are the errors that can be influencing the result? So the errors that can be occurred when adjusting the flow rate, as we have to wait for 5 minutes before recording the temperature reading, or else the result might be vary from the true value. Next error that can be occurred is the eye position cannot be directly proportional to the reading of the flow rate meter, and if the eye position is not directly proportional, it will cause some difference from the actual reading. For example, if the reading is showing 300 degrees Celsius mean, if our eye position is not direct, means the reading will be around 290 degrees Celsius, which means it won't be any accurate. So for question number 6 is how and what is the way to increase the accuracy for the experiment result? So the way to increase the accuracy of the experiment result is we have to make sure the eye position is directly proportional to the reading of the flow rate meter whenever setting up the flow rate meter. This will make sure that the flow rate is being set up as instructed and the outcome reading will be more accurate, which means the eye position should be directly proportional to the meniscus of our flow rate meter. So the next way is we can wait for 5 minutes before recording the temperature reading, since it will take time at least 5 minutes to reach the expected temperature. In case we need at least 100 degrees in order to reach the flow rate meter, means we have to wait until at least 5 minutes in order to have the expected temperature to be reached. So that's all from me. Thank you.
I will enjoy it with matrix number of MA20067. I'll present about the conclusion of the lab. For the conclusion, the heat transfer in different heat exchanger was analyzed. It was concluded that at the measured through flows, the greater resistance increased the heat transfer. And also, the counter flow is more efficient than the parallel flow. The double pipe heat exchanger has two types of flow, which is co-current and counter current. The hole and the cold liquids enter the heat exchanger at the opposite ends. The flow in the opposite direction is used as a counter current. The study revealed that the higher temperature increased the efficiency of the heat exchanger. This effect is mainly due to the higher flow rate of the fluids in the heat exchanger. For the reference, these are the three main references we used during our progress of our labs. Thank you.